friends, relax, sit back and listen to our math class. In today's class, we are going to learn the concept of finding the adjoint of the matrix for 2 by 2 matrix and for 3 by 3 matrix. This is for 2 by 2 matrix. Adjoint of A we are finding. So adjoint of A can be written as A, D, J, A. Okay. So adjoint of A for this matrix is, for 2 by 2 matrix, you have to change the position of these elements. So DA. This AD is now changed to DA, and then you have to change the sign of this one. So minus B minus C. This is the adjoint of a 2 by 2 matrix. So adjoint of a 2 by 2 matrix means whatever elements here you have to change the position, and for these elements you have to change the sign. This is for 2 by 2 matrix, and this concept is for 3 by 3 matrix. So for finding the adjoint of a 3 by 3 matrix, first you have to find the cofactors, and next you have to take the transpose of the cofactor matrix. That's what your adjoint for a 3 by 3 matrix. Let us do a problem based on this concept. Now we are going to find the adjoint for a 3 by 3 matrix. So we are going to find adjoint by using the concept of minor and cofactor. So before watching this problem, kindly watch that video. The link is in description. This is the formula for finding the cofactor. Cofactor is a signed minor. That means first you will find the minor, and you are changing by this cofactor, the sign of that minor will change. So instead of using this formula of cofactor, you can keep this in mind, that the first element, according to our cofactor concept, the first element will be a positive one, second element negative, third element positive, negative, positive, negative, positive, negative, positive. The positive and negative will be in alternative positive and negative signs. Okay, according to our cofactor concept. So keep this in mind. Next, now what we are going to do means, we are going to find the minor of each of these elements, and in that minor we are going to apply this sign. So minor of this element, first one. So minor of this first element means you will delete the corresponding row and column. So by deleting the corresponding row and column, what you will obtain? This part you will obtain. This part you will obtain. So 2 into 3, 6. 2 3s are 6. Minus 1 into minus 3, 3. Equal to 3. So here, cofactor matrix. This is cofactor matrix. So write it as Aij equal to cofactor Aij equal to, first element will be in positive sign and the minor is 3, because 2 3s are 6, minus 1 into 3, 3, 6 minus 3, 3. So 3. Next, second element will be in negative sign. So minus, deleting the corresponding row and column, 1 into 3, 3, minus 2 into minus 3, minus 6. So 3 plus 6, your answer is 9. So minus 9. Next, for this element, deleting the corresponding row and column, 1 into minus 1, minus 1, minus 2 into 2, 4. So minus 1, minus 4, minus 5. The sign is plus, so minus 5. Since the sign is plus, there is no change. You can write that minus 5 as it is. Next, for this one, deleting the corresponding row and column, 1 into 3, 3, minus 1 into 1, minus 1. So 3 minus plus. So 3 plus 1, 4. So you will write the 4 here. The sign is minus, so minus 4. Next, for this element, deleting the corresponding row and column, 1 into 3, 3, minus 1 into 3, 3 minus 2 into 1, 2. So 1 The corresponding sign is plus, so 1. Next, for this element, deleting the corresponding row and column. 1 into minus 1, minus 1. 2 into 1, 2. So minus 1, minus 2. So minus 3. Because deleting the corresponding row and column, 1 into minus 1, minus 2 into 1, 2. So minus 1, minus 2, minus 3. We have to check the sign. Here sign is minus. So I will put a minus here. Minus minus will become plus. So it will become plus 3. Okay. Next 2. For this 2, I am writing here. Deleting the corresponding row and column, minus 3, minus 2 equal to minus 5. Deleting the corresponding row and column, 1 into minus 3, minus 2 into 1, 2, so minus 5. Sign is plus, so write this minus 5 as it is. Next, for this one, deleting the corresponding row and column, so 1 into minus 3, minus 1 into 1, 1, so minus 4. So here already minus is there, minus minus plus, so plus 4. Next, for this element, deleting the corresponding row and column, 1 2s are 2, minus 1, 1. Sign is plus, so 1. This is our cofactor matrix. Next, we are going to find the adjoint by using this cofactor matrix. So adjoint of A, adjoint of matrix A equal to transpose of this cofactor matrix. This cofactor matrix is Aij transpose. If you are taking transpose of this matrix, then that's what your adjoint is. So 3 minus 4 minus 5 minus 9 1 4 minus 5 3 1 transpose. You have to take the transpose. So equal to transpose matrices. You will write the column. You will interchange the position of row and column. So 3 minus 4 minus 5 minus 9 1 4 minus 5 3 1. This is your adjoint matrix. So adjoint A equal to this is your adjoint matrix. Okay. 3 minus 4 minus 5 minus 9 1 4 minus 5 3 1. So we found the adjoint of this 3 by 3 matrix by first finding the cofactors and minors and then taking the transpose of the cofactor matrix. Thank you for watching. Subscribe to our channel for more videos related to both school and college maths. Thank you.